In this video, we will learn to graph and evaluate piecewise functions such as this one right here. Alright, now a piecewise function is two or more functions that are sort of put together, and the way you know which part of the function to use is based on what you have right here, which is called the domain. So this tells you for which x values to use the top function and which x values we're going to use the bottom function. So if x is less than -2, it's going to be the top function. If x is greater than or equal to -2, it's going to be the bottom function. So if I want to simply evaluate, so here I've got an x value of -8. Well, is that less than -2, or is that greater than or equal to -2? Well, -8 is less than -2. So that tells us we're going to be working with the top function. So that means that we're going to be doing 1/2 times x, and my function disappeared, so that's great, and -6. That's what we're going to be, basically we're doing the top function. And I don't need a calculator for this because 1/2 of -8 is -4, and -4 minus 6 is -10. Alright, if you need to put this in a calculator, feel free. Now, what about f at 6? Well, again, I've got these two different parts to my piecewise function, so I need to look at my domain. 6 is greater than or equal to -2. Alright, so I'm in this part of the domain, which means I'm using this particular part of the function. So that means I'm doing -2 times x minus 5, because that's what this function says to do. So that's going to be -12 minus 5, which is going to be -17. Started to mess up a little bit there. Okay, -17. So that should be my answer to B. And what about C? The value of the function at -2. Well, which domain is this going to be in? Is -2 less than -2, or is it greater than or equal to -2? Obviously, -2 is equal to -2, which puts us in this part of the domain, which means, once again, we will be using this part of the function. So -2 times x minus 5. So in other words, -2 times -2 minus 5. Negative times a negative is a positive, so that makes -1. Okay, so that's how you evaluate a piecewise function. Decide based on the domain which situation you're in, which part of the function you're using, and then just use that to evaluate. Alright, now how about this graphing business? Alright, so down here we're going to graph this function. So look, here's the deal. When you look at these functions, I want you to think y equals the top function and y equals the bottom function. Alright, this is a y equals mx plus b type situation. These are lines in this particular case. So we're dealing with two lines. So if I were to graph the top line, and you know what, I think I will use different colors. So for the top function, I'm going to be using blue. So if I'm going to graph y equals 1/2 x minus 6, what I would do is I would start by going to -6, because that is my y-intercept. Okay, that's the b in y equals mx plus b. So I will go to -6, and I'm going to put a dot right there. Okay, so there's my dot at -6. Now, because the slope is 1/2, I'm going to go up 1 and right 2. Up 1 over 2. Okay. So up 1, right 2. And I will do that over and over again. Up 1, right 2, up 1, right 2, up 1, right 2. And I will do the same thing going to the left. I will go down 1, back 2, down 1, back 2, down 1, back 2, down 1, back 2. So these dots, these blue dots are showing us what the top function looks like. Okay, now, but here's the key, the domain. The top function is only valid for some x values. It's only valid for x values that are less than -2. Okay, so looking back at my graph, here are the x values that are less than -2. It starts here and it goes over like that. Okay, so here's what we're going to do. Because it's less than -2, all right, you see I've got a dot right here at -2. Okay, it's this dot right here. But I'm going to make this an open circle because it said less than. Okay, we can't include the -2. All right, so there, by making this an open circle, I'm leaving out the -2 as I should. All right, if it had said less than or equal to, I would have made this a closed circle. So I'm going to include the part of this blue line that goes to the left. All right, because that's my domain. So so going to the left, that's going to include all these values over here, and I'll go ahead and draw that in. All right, so here is a picture of the top part. Okay, so I've now drawn y equals 1/2 x minus 6, but only the part where the x values are less than -2. Now I'm going to go ahead and erase the other dots here so I don't get confused. Okay, I'm done with that yellow as well. So I'm going to erase this because all I have for the top function is this. Now I'm going to go ahead and do the other part. Now this time I'm going to use this pink color. So now I'm going to do y equals -2x minus 5. So again, my y-intercept is -5, so I'm going to start there. Okay, so here's -5. Alright, so there's my y-intercept right there. Now the slope is -2. That means -2 over 1, which means I'm going to, when it's positive, I go up. When it's negative, I go down, but I always go to the right. So I'm going to go down 2, right 1, over and over again. Down 2 because it's negative, right 1. Okay, so starting from here, I'm going to go down 2, right 1, down 2, right 1. And I'm out of space, but if I went again, I'd go down 2, right 1. It'd be something like that. Now I can trace this pattern backwards by going up 2, back 1, up 2, back 1, up 2, back 1, and so on. Now I can see that this is where it's going to cut off, but I could have kept going if I needed to. But this function begins where the other function ended. So I'm going to take note of that. The domain is x values that are greater than or equal to -2. Okay, so again, it's all about -2. So here's -2. But this time I want values that are greater than or equal to -2. So I'm going to start at -2 and I'm going to go to the right. But this time I want values that are greater than or equal to -2. So see this dot right here? This dot is equal to -2. So what I'm going to do is, instead of doing an open circle like I did last time, I'm going to do a closed circle because equal to -2 includes this endpoint. All right, so and then I'm going to go ahead and draw in the values that are going to the right, because here the yellow, I'm showing you the domain greater than or equal to -2 goes to the right. So this point is, or there won't be any points over here to the left, so we'll go ahead and erase that. And I'm just going to go ahead and draw in these pink points right here. Okay, so it's going to look like this. Okay, it's got a little crooked there, but you get the idea. So this is what this graph should look like. So now we've graphed a piecewise function. Notice this is still a function. It still passes the vertical line test. If I draw a vertical line anywhere, it's only going to hit one point at a time. All right? If you pay attention to whether or not your graph is a function, that's going to help you avoid many of the mistakes that students will make. Because oftentimes I will have a student that draws a line in the wrong direction. So say if I drew my pink line going to the left instead of to the right. Well, right away, if you're paying attention to whether or not that's a function, you're going to see that that's a fail. That fails the vertical line test, all right, because the vertical line would hit that twice. So as soon as you see that, you know you made a mistake, and you're going to go back and catch your mistake, and you're going to see it should have gone the other way. So please make sure any graph you draw passes the vertical line test. A vertical line should only hit one point at a time. Notice that it even passes the vertical line test right here at -2 because the blue is an open circle, whereas the pink is a closed circle. So I'm really only hitting the pink point. I'm only hitting 1 point even at -2. Before I end this video on problem number 1, let me point something else out to you. We evaluated the function using the equation, all right, and we got these values. But for values that are on the graph, you should also be able to use the graph if you graphed it accurately. So let's go ahead and take a look at that. So for example, f at -8. Let's see what that looks like. I should zoom in. Okay, so f at -8. Now again, this is an x value of -8. So if I go to -8 on the x-axis and look around. So here I am at -8. To get to the function, I'm going to have to go down to here. And notice that right here, the function has a value of -10, which is the same thing we got before. All right. Now, this one is off the graph, so I won't be able to use that to show you. But what about this one? F at -2 itself. So I'm going to go to an x value of -2. So if I do that, here I am at an x value of -2, and then sure enough, I look down, and boom, here's the function right here. At -2, the function has a value of -1, as you can see. Okay, we're talking about the y value is -1. And that's the same thing we got by using the equation. All right, so that's another way to evaluate if it's on the graph.